Okay, so let's apply that last theorem. Okay, so if you take a look at this example 2, all right, what we have is our two secants that are intersecting on the exterior, all right, of that segment. Okay, so exactly what we want to see. So let's go ahead and solve this formula. So let's go ahead and look at this first one. So remember what the idea is. We're going to take the outside segment and then multiply it times the product of the entire segment, okay? So if I would do this for the first secant, is I'm going to take the exterior segment of 8 and multiply it times the expression to represent the entire segment, which is x plus 8, equals. All right, same idea is I'm going to take this exterior segment of 6 and then multiply it times the entire segment of 16, all right, because I add those together. So I take the exterior segment of 6 and then multiply it, all right, times that entire segment's length, which is 16. So distributing through, all right, we're going to have 8x plus 64 equals 6 times 16, which is 96. All right, solving this, I'm going to subtract out that 96. I'm going to subtract out that 64. So I'm going to do 96 minus 64, and I'm going to get 32. So 8x is equal to 32, all right, which means that x is equal to 4. Okay, so that one was nice and easy. All right, let's go ahead and try this next example, okay? So looking at this one, I see I have x on the outside, and then I need to find the length of the full segment, all right, which is x plus 9. So I'm going to do x times, in parentheses, x plus 9 equals, same idea here, all right, is I'm going to take this 4 on the outside, so the exterior point, and then multiply it times the entire segment of 9. So 4 times 9. So here we go, guys. If I distribute that x through, I'm going to get x squared plus 9x equals 36. All right, and not so nice is I'm going to have to factor. So I'm going to take this 36, I'm going to subtract it over, and I'm going to have x squared plus 9x minus 36 is equal to 0. So from this point, guys, all right, we have to see if it can be factored. And I know yesterday I made you guys watch a video on quadratic formula, so you can know that you can use a quadratic formula anytime, all right? But I like to see if I can factor first. So what I need to find is I need to find two numbers that multiply to get a negative 36, but add to get a positive 9. And I'm going to find that those two numbers are a 12 and a negative 3. So what that means is that I have x plus 12 and x minus 3 as my factored form of this up top. So taking those individually and setting them equal to 0, I'm going to have x plus 12 equals 0, which means that x is equal to negative 12, and then x minus 3 equal to 0, which means that x is equal to positive 3. And since we're talking about lengths, the negative 12 doesn't work, so your final answer is x is equal to positive 3. Okay, so we're going to do our last example here, all right? And in our last example, what we have is we have a tangent and a secant that intersect from an exterior point. Okay. So again, we have this exterior point. So let's draw the picture, and let's draw a circle. And let's go ahead and mark our exterior point on the outside. And what we're going to do is we're going to draw our we're going to draw our tangent so that it comes up to the top. So let's draw our tangent, and let's mark that point of tangency. And then let's draw a secant so that it's intersecting twice through that circle. So 2 points of intersections. And so let's call that top point of tangency A. Let's call the exterior intersection point B. And let's go down through that secant and do D, C, and then D. So let's actually start with the secant, because this is exactly like the one that we did before, all right, where we're going to take, whoopsie, all right, where we're going to take that exterior segment of BC, and then we're going to multiply it times the entire segment of BD, all right, so we're going to do BC times BD equals, and the issue here is that we don't have, all right, an exterior and a full segment of the tangent, because all we have is this exterior segment. So what that's going to equal then is just the square of that exterior tangent, so AB squared. Okay, so one more time, all right, just to talk through that. All right, we have that external times the total is equal to the tangent squared. All right, so that's just the kind of idea of what's going on. So let's now apply it. So let's take a look, all right? It's a little blurry. I definitely recognize that, all right? So it's a little blurry, but here we go. So this little segment right here is x. So what we have here is we're going to take that external segment of x and then multiply it times the entire segment of x plus 7. So I'm going to have x times x plus 7 equals that tangent squared, so 8 squared. So distributing through, I'm going to have x squared plus 7x is equal to 64. And because my x squares don't cancel out or anything like that, I'm going to subtract that 64 over. So I'm going to have x squared plus 7x minus 64 is equal to 0. So at this point, what you could do is you could see if there are two numbers that multiply to get the negative 64, add to get a positive 7. But we're not going to waste too much time here, because what you're going to find is that there isn't this magic pair of numbers that does that multiplies to get the negative 70, or that multiplies to get the negative 64 and adds to get 7. So this is the case where we have to use our quadratic formula, all right? And here's what our quadratic formula is, all right? So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you watched my video yesterday, all right, where we get these a, b's, and c's is actually from this quadratic. So the a is always going to be the number in front of the x squared. So in this case, it's 1. All right, the b is always going to be the number in front of the x. So in this case, it's 7. And c is going to be the number that's by itself. So that's going to be the negative 64. And you got to take the signs in front of it. So we're going to take this a, b, and c and plug it into that quadratic formula. And again, if this is too fast, I have an entire video, all right, that's describing how to do this, okay? But what I'm going to get is the opposite of 7, so negative 7 plus or minus the square root of 7 squared minus 4 times 1 times a negative 24, I'm sorry, a negative 64. And I actually don't like how I wrote this. I'm going to get rid of these times, and I'm going to put parentheses in there. All right, all over 2 times 1. So simplifying, all right, I'm going to do negative 7 plus or minus the square root of 7 squared, which is 49. And then I'm going to multiply a negative 4 times 1 times 64. And I'm going to get 256. So this becomes plus 256, because a negative 4 times a negative 64 becomes plus all over 2. And then I'm going to add the 49 and the 256, and I'm going to get 305. So negative 7 plus or minus the square root of 305 all over 2. And so what we're going to do for this is we're actually going to do decimals of this, okay? And because I'm talking about length, I want to just make sure that my answer is positive, all right? Because typically you would have to do 2 different cases, all right? So I'm going to just quickly talk about this. You do negative 7 plus the square root of 305 all over 2. And then you do negative 7 minus the square root of 305 all over 2. But here's what I would notice is that this answer right here is going to be negative. So I'm not even going to bother doing that, right? Because I don't want my negative answer, okay? So what I'm going to do is I'm going to take the square root of 305, all right, and I'm going to round it to 2 decimal places. All right, so I'm going to take the square root of 305, and I'm going to get 17.46. So I have negative 7 plus 17.46, whoopsie, 46, all over 2. Adding those two up top, I'd get 10.46 divided by 2, which gives me my final answer of approximately 5.23. So all of that work means my final answer is approximately 5.23. Okay, so we're going to try it again. All right, so we're going to do this next example. And here we go. All right, so we're going to take our secant and we're going to do x. All right, and then we're going to multiply it times the entire secant. And so I'm going to have x times, and if I add those two together, I get 2x plus 4 equals 10 squared. So distributing through, I'm going to get 2x squared plus 4x is equal to 100. And then I'm going to subtract out that 100, and I'm going to have 2x squared plus 4x minus 100 is equal to 0. And from this, I'm going to take my a, my b, and my c. My a is 2, my b is 4, and my c is negative 100. So substituting into your quadratic formula, so negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, substituting into that, I'm going to get negative 4 plus or minus the square root of 4 squared minus 4 times 2 times a negative 100 all over 2 times 2. So simplifying underneath that radical, all right, I'm going to get negative 4 plus or minus the square root of 16. And now I'm going to multiply negative 4 times 2 times a negative 100. And I'm going to get 800. So that becomes plus 800 all over 4. I'm going to add the 16 and the 800. And I'm going to get negative 4 plus or minus the square root of 816 all over 4. And now I'm going to take the square root of 816, and I'm going to get 28.57. So what I'm going to simplify now is just the positive version of that, so negative 4 plus 28.57 all over 4. So I'm going to do 28.57 plus a negative 4. Divide that by 4, and what you should get is approximately 6.14 for your final answer. Phew. All right, so I'm going to pause there, and then I'm going to come back, and we're going to do a few more examples.